In this video, we are going to start Chapter 12 by talking about the first three concepts in the chapter. We'll talk about what chemical bonding is, the octet rule, which is used to predict bonding, especially in introductory chemistry, and then the comparison of ionic and covalent bonding. So let's get started. So first, let's just define bonding. So bonding is the word that chemists use to talk about when atoms are attached to each other. And when atoms attach, they form things like molecules. So here you can see the reason that the atoms are bonding to each other is because they are becoming more stable. So in terms of potential energy, stability comes when the potential energy is lower. And so bonding for atoms can lower their potential energy so they become more stable. Now, the electrons are involved in reactivity and chemical bonding, and specifically, we're going to be using the valence electrons. So during this chapter, there'll be lots of talk of valence electrons because those are the ones that are involved in the bonds. Now, in a previous chapter, there was mentioned that there are two types of compounds. We call them ionic and molecular. And these categories of compounds come from the type of bonding that are inside of them. So you can see we have ionic and the covalent bonding. And covalent bonding is what is a part of, or what holds together, maybe I could say, the molecular compounds. And so in this introductory chemistry class, we really are going to be looking at the octet rule and how it applies to the bonding in many of the main group elements. And as a reminder, the main group elements are all the tall columns, or they're the ones that have A in their group number. So it's 1A through 8A. On the periodic table, they're the taller ones. So let's talk about the octet rule, and we're going to go over both ionic bonding and covalent bonding, and we will apply it specifically to both of those types. But here is the general rule. Elements will lose, gain, or share valence electrons. Those are the ones that are involved in bonding, to reach the electron configuration of the noble gas closest to them on the periodic table. So my question that I would have you consider is, why would atoms want to have the same electron configuration as a noble gas? So think about it. See if you have an answer. Okay, I'll come back to it. And so we're going to use this octet rule to both predict the charges and to predict how covalent bonds are formed. So we're going to use both ionic and covalent. So now I'm circling back around, I don't even know why I said that, to the idea that why would atoms want to gain or lose or share to be like a noble gas? And maybe you answered to the screen. So noble gases have a complete valence shell. They have all of their S's and all of their P's. So I'm putting in there because I don't know which one it is, but they have 2 S's and they have, oops, I wanted to write another N, sorry. 6 P's. So except for helium, they have 8 valence electrons. Okay, so they're completely full. And this configuration is very, very stable. In fact, the noble gases are really, for the most part, non-reactive because they don't need to react to be stable. They are very stable. I slid right past the idea that helium doesn't have 8. Remember, helium is in the first period of the periodic table, and it only has the s orbital. So for helium, a complete valence would just be 2. So before we move off this again, I just want you to think about the octet rule. It will come back in a different video, but their elements are going to lose, gain, or share their valence electrons to have the same electron configuration as the noble gas, because noble gases have very stable electron configurations, and bonding is all about stability. The other thing I want to remind you is these elements are not becoming noble gases because it's the protons that determine the identity of the atom, not the number of electrons. So our elements are not becoming noble gases. They are just having electron configurations like noble gases. So let's just compare these two types of bonding, and we're going to look at them in more detail and predict some things about them. But I always appreciate a table like this because I like to see how things kind of compare and contrast. So we have the type of bonding as ionic and covalent. And then I mentioned in just the previous slide that it's valence electrons. And so in ionic bonding, the valence electrons are going to be transferred. That is going to be where they lose and gain electrons. Now there's two words here that we're not familiar with yet, cations and anions. I put them in this table so if you went back to review that you would it would give it a little more clarity. We're going to learn about cations and anions coming up here real quick. And then if you look down at what the electrons do for covalent, they're shared. So remember, octet rule said lose, gain, and share. So losing and gaining are for ionic compounds and sharing are for covalent. Now, this is what we really talked about in the previous chapter is how can we determine by what the elements are, what type of bonding they have. And so it's metals and nonmetals that form ionic bonds, and nonmetals to other nonmetals form covalent bonds. This is an important idea that you're going to need not only for this chapter, but also in things like naming and in predicting some things in chemical reactions. So this is good to put in your mind that metals and nonmetals form ionic bonds and nonmetals form covalent bonds. And remember, we can use the periodic table that has a stair-step line on the kind of the middle of the right side, and that's the dividing line between metals on the left of that and nonmetals on the right. That's in a previous chapter if you want to go back and review that, but it's still helpful information. And then the other thing that we want to consider is how these form. When they form, how do they form? And ionic compounds, they call them formula units. They do not form individual units called molecules. So, and I have a slide on the next one, the next slide that gives you an illustration. Molecules are individual units, and ionic compounds, they have a unit in their formula, but these are actually in a crystal structure. So they don't have individual. Now, this might be kind of hard for you to imagine, so let's look at the next slide. I have an illustration. All right, so this is illustrating ionic and covalent. So right here, this dry ice, this is covalent. It's carbon dioxide. And do you see covalent bonds have molecules? Do you see how it just has little individual units of carbon dioxide? When they say molecule, that's what they're referring to. Now the sodium chloride there on the right, this is, if we write the formula, it's NaCl. That is a formula unit, like it tells me the ratio. But it's in a crystal, and the crystals have a pattern, and you can see here, but there's lots of different positive and negative. These, in this case, these are the negative ones, and these are the positive. And so like little magnets, these sodium ions and chloride ions all come together. And so there's not one individual unit. it's called a formula unit because we know it's a 1-to-1 ratio, but in the structure, there's lots of the positives and negatives next to each other in a 1-to-1 ratio for sodium chloride. If the ratio was different, and it can be, it would still have a cluster like that, a patterned cluster, but the pattern could be different. Okay, so just kind of get in your mind that you can imagine the difference between a molecule and what ionic compounds do in the crystal structure. So here's a practice, and so I'd encourage you to pause, and this little practice just helps us use the formula to decide if something's ionic or covalent. So just pause the video, try to answer it, and then you can start it again and hear my explanation. So what we're going to use when we're asked this type of question is what type of elements are involved. So ionic are nonmetal and metal. And so now I just caught myself. I'm going to write metal first because in the formulas and in the names, the metal always comes first. So it's helpful for me to think of it that way. So metals and nonmetals, and covalent compound, we just use nonmetals. And how we determine that is we would use the periodic table. Now, over time, you may remember what some of them are in reference to metals and nonmetals, but it's not required. So letter A, there's carbon and oxygen present. They're both nonmetals, so this is covalent. Letter B, aluminum is a metal and oxygen is, so this is a metal, this is a nonmetal, so metals and nonmetals are ionic. This one was nonmetal, nonmetal. Potassium fluoride, potassium is a metal, fluoride is a nonmetal, so metals and nonmetals are ionic. And the last one, CH5N, we have nonmetal, nonmetal and nonmetal. So even if there's, even if there's more than one element, and more than two elements, you still could apply the same rule. So those are all nonmetals, so that is covalent. So that's a brief introduction about how we're going to view bonding. So now in the future videos, we're going to get a little more specific and learn about ions, molecules, Lewis structures, and things like that.